If $20,000 is invested in a savings account offering 3.5% per year, compounded continuously, how fast is the balance growing after 3 years? What if the interest is compounded semi-annually? How fast is the balance growing after the same amount of years? With compound continuous, we would use the equation P equals P naught E R T, where R is 3.5% or 0.035. Put it in a function notation, we have f of t equals, the principal is 20,000, R is now 0.035 t, where the variable t represents the time in years. The initial investment is 20,000. The question asks for how fast, which means that we would need to find the rate, but the rate is derivative at prime of t. This is derivative of f. 20,000 is a constant multiple, so we would rewrite this. The derivative of e to anything is e to the same thing. We rewrite the exponent first, and then we multiply the derivative of the inside function, which is the derivative of 0.035t, which is 0.035 with respect to t. Before we plug in 3, we should simplify this. At prime of t equals 2000 times 0.035 is 700. E raised to 0.035t. After 3 years, where t is 3, we substitute t with 3. This is 700 e raised to 0.035 times 3. Put this in a calculator. We will get $777.50, which means after 3 years, the account or the balance will be growing by $777.50 per year. This is how fast the balance is growing. Now, if the interest is compounded semi-annually, we would use the equation P equals P naught 1 plus R over N raised to the power of NT. In this case, since the interest is compounded semi-annually, and so N equal 2. Rewrite this, we have g of t, we will use a different function. Earlier we used f, this time we will use g. The principal or the initial investment is still 20,000. 1 plus R is 0.035, N is 2, and then the power is 2t. We will need to find the derivative because the question asks for how fast, but before we do that, we want to simplify this if we can. G of t equals 20,000. 1 plus 0.035 over 2. 0.035 over 2 is 0.0175 plus 1, so we get 1.0175, and the power is 2t. We then find the derivative. G prime of t equals 20,000 is a constant multiple. The derivative of any base raised to a power is the same, 1.0175 raised to 2t, but then since the base is not e, we would need to multiply ln of the base. So this is ln of 1.0175, but also the inner function is 2t. 2t is inside this exponential function, so using the chain rule, we will still need to multiply 2. Simplifying this by taking 20,000 times ln of 1.0175 times ln of 2, we have g prime of t equals 693.9455. We still have 1.0175 raised to 2t. Then we plug in 3. G prime of 3 equals 693.9455 times 1.0175 raised to 2 times 3. Before using a calculator, we should multiply 2 times 3. So this expression is now 693.9455 times 1.0175 raised to the 6th power. Put it in a calculator, we will get $770.70, but the units will be dollars per year. What this means is that after 3 years, the balance will be growing by $770.07 per year. Observe that this number is a little bit lower than the previous answer, and that is because we always earned a little bit more with continuous compound.